Hello and welcome to the second international student competition FoodFactory for us today on the 7th of June. My name is Line Lindner. I'm from the ISEKI-Food Association in Austria. And before I hand over to Paola, I would just like to give a short introduction to the system, GoToWebinar, because we are people sitting all over Europe and even the world. So, and for many of you, it's the first time that you're using the system. Therefore, I will just shortly explain to you how it works. As the teams already know, they have 15 minutes for the presentation, and then there will be 5 minutes for questions, and all the microphones should be muted during the presentation to avoid too much background noise. And if there are questions from the attendees, I can open their microphone. You can just raise your hand and let me know if you have a question. Otherwise, you can also type your questions in the questions pane, and I can read out the questions loud to the teams. Yeah, I think for my part that was it. Then I will hand over to Paola now.
Thank you very much, Line. So I switch to my presentation then. Here I am. So just a brief introduction to this morning. First of all, I would like to thank you all for participating to this second edition of the FoodFactory for Us, supported and sponsored by the European Food Star Project, and sponsored, that we will be saying later, also by the ISEKI-Food Association and the Jessica Association. This is the outline of this morning, very briefly, and we hope to finalize everything by 1 o'clock this morning. I think that Lina has already told you something about the GoToMeeting tool that we have. Just a brief also graph of the meaning of the different tools available in this software during your time here in at the final virtual workshop. If any question, raise your hand. Here you have to raise your hand, so you have just to click here and we will try to sort it out. To write, this is the chat box, and you can obviously write the questions to the panel, to us, and we will then deliver them to the team or to the board. As I told you, this activity is organized, has been supported and organized within the EU Food Star Project, which is an Erasmus Knowledge Alliance that is finishing now, as the aim to stimulate and trigger innovative education, trying to target this education towards the needs of the industry in order to improve the employability. And then also the idea, the target was also to facilitate the innovative continual professional development, so to be somehow proactive for the career development of the graduates, but also an exchange, share, and the co-creation of knowledge between academia and industries. So the main keywords you can see are industry staff, students at most, teachers and training, working from this point of view together. The main outcome of this project is the development of an EU Food Star Center that will continue to work beyond the end of the project and will be hosted within the ISEKI-Food Association. So for more information, you can visit our website, the website of the ISEKI-Food Association, where you will find all the information and activities that are somehow shared between local and national centers. One of these is located in Italy, one in Portugal, one in UK, one in France, one in Hohenheim in Germany, and one in Vienna. Main activities that will be carried out within this center will be the continuous organization of workshops, like also in the training and the food factory for us, for sure, webinars, and I will remind you the next one organized by that will be delivered by Professor Pier Giovanni. We will continue to organize also online courses and a series of other tools that will be made available for any interested person, and most of them will be open source. Another important activity of the EU Food Star Center will be has been the development of a platform, a virtual platform for the continual professional development, and I invite all of you to visit this website, because soon we will be more active also in this respect. Let's go back to our competition. This was the second edition of the Food Factory for us, and the main objective is the improvement of practical knowledge and abilities in solving real problems of the food industry, in order to allow the students and the graduates to exercise themselves by using also the knowledge that somehow academia is delivering them during conventional teaching methodologies. Moreover, the aim is also to improve and implement some skills like communication, like the team working, and the problem solving. Another idea was to favor the interaction among students from various universities, and I'm very happy, for instance, that at this time we had a mix, a team made by two universities, because they were friends from different universities, and they joined, they joined in order to develop the project that has been also submitted at the end of the competition. The second edition had a different target topic in respect to the previous one. Actually, in this case, in this 2018 edition, the main thematic objective was the development of strategies and actions aimed to enhance the shelf life of foods, because this is a main topic or a main aspect or problem that the food industries are nowadays facing, in order also to optimize the distribution, the transport, the logistics, but also all the aspects related to the market, of the products, taking into account a market that actually has become international, global, So we have to provide more important additional actions and solutions to enhance safety and quality of the products. So this was our challenge, and obviously these some ideas we listed were related to the formulation changes, the innovative processing application, the use of biopreservation or innovative packaging, and aspects related to the distribution and logistics. Our sponsors were and actually are the ISEKI-Food Association, which is the ISEKI-Food Association is an organization that works a lot via also virtual tools aimed to promote synergies between research, education, and industries via a series of diverse activities and actions aimed overall to improve the quality of higher education and food studies and bridging education with research and industry businesses. Actually, we, as regards the quality improvement of higher education and food studies, I just mentioned here the ones that are actually aimed also for students. So if you are interested, you are welcome to join us because we are developing and developed a lot already a series of training material. We have a databases with interesting training and teaching materials, along with an e-learning platform with a series of online courses. As regards the bridging education with the research and industry business that can be also of interest for you is the fact that we organize forum conferences, and I just mentioned to you the next 5th International ISEKI-Food Conference that will be held in Stuttgart in 1 month ahead. We have also set a series of other tools like we have the International Journal of Food Studies, which is an open source peer-reviewed international journal, and we have also a series of special interest groups that develop specific interesting activities within our association. The second sponsor was JESICA. This is an acronym of an Italian name that by translation in English, it means Italian Scientific Group of Food Packaging. Actually, they are based in Italy, but they have an international dimension, and their activity is aimed to encourage the growth and diffusion of food packages in scientific culture, to represent the Italian research in food packaging, but not only, because their network is actually international, is fully international, and also to promote the interaction between the public and private research, putting together industry representatives and researchers, scientists, and just to mention, JESICA has a partner important industries like Ferrero and also Barilla. They organize also, they are working on a series of areas, and they organize also a conference, and I just would like to mention that in Naples, 20 June 2019, they organized the Shelf Life International Meeting, which will be an international conference dedicated to the shelf life. FoodFactory for us was supported by a scientific committee And here you have all the list of the members, Florence Dubois-Brissonnet, Cristina Silva, Gerard Schleining, Luciano Piergiovanni, Christophe Cotillon, and myself as a chair. And I would like really to thank all of them for their contribution during the entire time of this second edition. We involved also an evaluation board for the evaluation of the reports and presentations, and this was made by a team of independent experts that evaluated your projects, your report independently. And here you can see that we had a representative of the ISEKI-Food Association, one of the JESICA, one from the Food Industry Association, and one representative of a food industry that evaluated the report, the PPT, and now they are also following our virtual workshop and presentation. So we are here actually now looking at the timing and the different steps that I presented already. So we are here, and now obviously is somehow your time. But who are you? Actually, at the beginning, we had 12 teams registered and that followed also the virtual and the webinars during the time of the duration of the FoodFactory for us. But at the end, only 7 teams submitted the reports as asked and as written in the instructions, and actually this anyway was a successful result, because it was similar more or less of the last year. We try to in this case also to allow you some training during this FoodFactory for us. That was somehow a way also to allow to get some additional hints to develop your project, but also to collect some ideas that can be helpful for finding the solutions for your project as well. And just I would like to thank again Rainer Schwacinka and Luciano Piergiovanni for the time dedicated in delivering the 2 virtual webinars. I would like already to remind you to register also to the last seminar, which actually will be next Monday. Again delivered by Luciano Piergiovanni on a really interesting topic that could be of interest for you and for your friends and classmates. And now is your time. So I am at the end of my presentation. Here are all the first slide of the PPTs that we received and we evaluate. Actually, here is the full list of and the timing for the presentation of each of you. This actually this list obviously and the timing was really not based on any criteria, just we think that this could be good for us, and we can from this point of view from now onward start with the first presentation that will be delivered by the fresh wind of food changes from the Black Sea. And good luck to all the teams. That's all.
Thank you, Paola. So the first team, Fresh Wind of Food Changes from the Black Sea, can you turn on your microphone and your webcam? Then I will give you the presenter control.
Sure. Wait a second.
Hi.
Hello.
Hello.
Very good. We see
Wait
your
a second.
presentation.
Here.
Mhm.
Yep. So
Right.
let's start. Good morning, everyone. Let me introduce myself. My name is Ivan Larionov. I'm the captain of the team Fresh Wind of Food Changes from the Black Sea. And we have prepared our project report with the title Application of a Hurdle Technology in Extending the Shelf Life of Meat Products. We divided our work in 3 different parts. Each of them was made by the master's and the postgraduate student. This is my team. This is Vladislav Gevrik. Good morning. Lyudmila Melnik. Good morning. And Anastasia Tropets. Good morning. So our project proposes a new approaches to the extending the shelf life of meat products. So we started with the hurdle technology. So what exactly is hurdle technology? Hurdle technology is the method of ensuring that all pathogens in meat products can be ensured and can be eliminated. This means that the food can be safe for consumption and their shelf life will be extended. This means that we need to use more than one approach. This approach can be thought at hurdles, so the pathogen has to overcome if it's to remain active in the food. So the right combination of these hurdles can ensure that all pathogens can be eliminated in the final product. In our project report, we are using the hurdle technology like physical hurdles. It's a high temperature, it's a low temperature, it's an ultraviolet radiation, packaging film, modifying atmospheric, and we're also using physicochemical hurdles. It's a low pH, ozone, CO2 extracts, spices and herbs, and lysozyme. We're also using like microbial hurdles. It's a competitive flora, protective cultures, and bacteriocins. Wait a second. Do you see me? Yeah, sure. So our part number 1 of our scientific research was the development of technology for the production and the use of edible coating with the hurdle properties of meat products. So the aim of our part number 1 of our scientific research was the searching of best possible options of edible coating with the hurdle properties with meat semi-finished products. So the objects of study were chosen the high antioxidant activity CO2 extracts of parsley, ginger, and also lysozyme of egg white, as strong as antibacterial activity component. So the subjects of study were model samples for natural pork semi-finished products, which kept up to 24 hours after the slaughter at 0 to 4 degrees. In our part number 1, we are using hurdle technology like physical hurdles. It's chilling, it's edible coating. We're also using physicochemical hurdles. It's a low pH, it's a CO2 extract, and also it's a lysozyme. On this slide, you can see our graphics. It's a fat per height value, and this is also exit value of fat. So we made 5 different samples of it. Each of them was stored for 1 day, for 3 days, and for 7 days. The samples were uncoated sample. It was coated sample without CO2 extracts. It was coated sample with a ginger CO2 extract. It was coated sample with a parsley CO2 extract and the norm. So we can say that about fat per height value, that the uncoated sample has more pH level than any other samples, included coated sample without CO2 extracts, as well as exit value of fat. On this slide, you can also see samples before dipping, without coating, and with coating after dipping. On this slide, we can see our pH level. And also we can see our lost weight after thermal treatment. So about pH level, we can say that the coated sample without CO2 extracts has more pH level than any other samples on the 7 days of storage. And we can say that about lost weight, that on the 7 days of storage, we get the same amount of percentages of lost weight in all 4 different samples. So at the next stage of our scientific research, we will be using a new edible coating, which will contain a gelatin, which has the properties of pasteurizer. We also will be using a beetroot concentrate, which has properties of a functional component, and we can get a color of it. And we also will be using an extract of lithozyme active additive from egg white. It hasn't already been developed. This technology of extract of lithozyme active additive, so this already was proved. So in the end, we can get an edible coating for chicken fillets. You can see our pilot sample on this picture. So this is our part number 2 of our scientific research, which has a name, application of activity influencing of ozone and ultraviolet radiation on the meat LTLT sous vide. So the aim of our part number 2 of our scientific research was to use the sous vide technology for producing safety and high quality products from chicken meat. An object of study were chosen chicken fillet. The subjects of our research were mathematical model for determination of the optional break temperature condition, have been sous vide treatment of chicken fillet, and also was envisaged to take a place treatment ozone and ultraviolet radiation surface of chicken fillet for destroying pathogenic microflora. On this slide, on this part of our scientific research, we was using physical hurdles like low temperature, long time, LTLT. We was using a chilling method where we was using ultraviolet radiation, plastic, and vacuum packaging. Also, we are using physical-chemical hurdles like ozone. On this slide, you can see our view. The cut chicken fillets are made using the sous vide technology. So we made also the mathematical modeling of our samples. So we made the dependence of the temperature regimes and the thickness of the final product from poultry meat on the degree of culinary rednesses of the product were determined using this mathematical modeling, and formulas were obtained just for describe the dependence of the temperature regimes sous vide samples at a given temperature and after given temperature of sous vide samples. On this slide, we can see our technological scheme of production of chicken fillet in a traditional technology and technology sous vide. We can see the left side is our traditional technology, the right side it's our sous vide technology. So we can say that there's 3 first steps is quite the same. But then in sous vide, we're using determination of thickness of raw materials and vacuum. Then we are bringing it to the condition. Then we are water bath. Then we are cooling, and then we are storing it for 6 days, not more than 8 degrees. We can see our view. The cut chicken fillet is made according to the traditional technology and technology sous vide. It's A and B, as you can see. Also, we made a comparative characteristics of physical-chemical properties of samples made according to the traditional technology and technology sous vide. So we can see our mass fracture of moisture more in sous vide, mass fracture of sodium chloride more in sous vide, yield more in sous vide, but losses are more in traditional technology than in technology sous vide. Also, we made microbiological properties of the samples, traditional technology and technology sous vide. So we stored them for 0, it was after cooking, for 1 day and for 6 days of storages. And we can say that on the 6 days of storages, the traditional method of storage period of traditional technology has more the amount of mesophyll and optional anaerobic microorganisms, colony generating items in 1 gram of the product than sous vide has on the 6 days of storage, in 4 times bigger. So our next step of our research of this our part will be using ozone and ultraviolet lamp for chicken fillet, which will get us a high quality of the product. we will get a safety of our product, and we will get like a nutritional value of our product. So this is our part number 3 of our scientific research, which is using biotechnological methods for modifying meat raw materials for prolongation of the shelf life of sausages. So this aim of our part number 3 was to prove the hurdle properties of the bacterial leaven based on cultures, Lactobacillus sakei and Staphylococcus xylosus. An object of study was modification minced sausages under the influence Lactobacillus sakei and Staphylococcus xylosus as well. The subject of scientific research was to study the possibilities of reducing the sodium nitrate content in the production of boiled smoked sausages and antagonistic effect of bacterial leaven. In this part, we're using hurdle technology like physical hurdles, it's a pasteurization and chilling. We're also using physicochemical hurdles, it's a low pH. And we're also using like microbial hurdles, it's a competitive flora, protective cultures, and bacteriocides. On this slide, you can see our comparative characteristics of samples of boiled smoked sausages with a decrease in sodium nitrate. 1 is control, and 2 is reduction of sodium nitrate by 30%. On this picture, we can say that there is no difference between like control sample and the sample with a reduction of sodium nitrate by 30%. Also, we made a reflective spectra of biomodifying minced meat with a mass fracture of 0.1%. Of all 7 samples, and you can see our graphics of wavelengths of this all 7 samples. So the color spectrum of the samples is being analyzed, which are at level of 25 to 30%. In the comparison with the references and the sample with a nitrate reduction by 30%, which indicates the formation of a large amount of nitrosamyoglobin, which are responsible for the color in minced meat raw sausages. In the work, we used mold fungi. This will get us to allow to show you the development of undressable microflora without mycotoxins. And we also get like Lactobacillus sakei produces a number of thermostable bacteriocins in the participation stage, and we also get like Staphylococcus xylosus because it prevents oxidation of fat fracture of action of air oxygen. On this slide, you can see our antimicrobial activity of leaven, Lactobacillus sakei and Staphylococcus xylosus. So we made 3 groups of it. It was Escherichia coli, Bacillus mesentericus, and it was Enterococcus faecalis. On this slide, you can see the study of antagonistic activity between bacterial leaven, Lactobacillus sakei and Staphylococcus xylosus in quantity. So we can say the bigger hole is, the more concentration of this bacterial leaven is there. On this slide, you can see our antimicrobial properties of leaven depending on the mass structure of application. And we can say that the results of this study of the properties of leaven based on the mass fracture of sodium application established that they are able to prevent the growth of putrefactive microflora in the case it's fall into the minced meat. So in the conclusion, we can say that the hurdle technology does not solely target microorganisms in food, but also embraces aspects of sensorial and nutritional quality, and the economies of food and distribution also. Effective application of the hurdle technology requires a truly interdisciplinary approach. This demands teamwork between microbiologists, technologists, nutritionists, and engineers, and even experts in the marketing of foods. Thank you for your attention.
Paula, you have to turn on your microphone, please. You have a problem, apparently. Okay. Well, thank you for the presentation. So if there are any questions from the attendees, you're very welcome to raise your hands and I can open your microphone. Or also from the other team, from the other teams, you're welcome to ask questions. You can just open your microphone yourself or ask the question in the question pane. I can read it out loud. Yes, wait a second. There's a question from Pilar. I will open your microphone, Pilar, then you can ask yourself.
Hello, good morning, everybody. Can you
Hello.
hear me?
Yes.
Yeah.
I just wanted to congratulate the team on the final sentence, which I really enjoyed. And I think it very much sums up the future of food, which is something we as a company are always looking into, which is the interdisciplinary approach. And I really enjoyed, I wanted to congratulate the team on the sentence. This demands teamwork between microbiologists, technologists, nutritionists, engineers, experts in marketing of foods. Well done.
Thank you.
Okay, finally I managed, because my mouse was not connecting to the computer, so I had this very silly stupid problem. Thank you very much. Really interesting presentation, different approaches, interesting solutions. One question, obviously you have focused your attention more on the shelf life of the products. However, what about the sensory acceptability of the products that you have tried to study or to project somehow, to experiment? I mean, if you use ginger, you can have also an impact on the taste and also on the aroma or flavor overall. Did you investigate also this aspect or not?
Let me answer this question like a captain of the team. So we're not using like a ginger like a vegetable. We're using like CO2 extracts with like a little percentage of a ginger. So there is no difference between, we don't get a sensorial taste of this ginger. So actually you don't even know this is a ginger in there. We're using because it's a functional component for this. Yeah.
Great. So you also selected the specific components in the ginger for the antimicrobial effects.
Yeah.
So it was really focused.
Yeah.
There is a question from another team, from the Imagineers team. I will open your microphone. You can ask yourself.
Hello.
Hi. Hello.
Hello. So you stated that you use NaNO2, like the sodium nitrite salt, in your one of the slides.
We don't actually use like a sodium salt. We use like a reduction. So we made less percentage of this salt because we get a bacterial leaven in there. So we can get a microbiological safety of the product. So we get a less concentration of this sodium salt, as you say. Okay,
because one of the slides where you had a kind of a salami or the picture of that, so there was different concentration of NaNO2 or something. So we thought, like, because it is proven that it can have some impact on inducing cancer on human health, and that is why we asked you. We had a query on this aspect.
We show you this picture because we get like a control sample from the really rare market, and we get like a sample with less concentration of the sodium nitrate. So we get there is no difference for the customer to see the difference between the reduction of sodium nitrate and the control sample. That's it.
Okay.
Thank you.
Thank you.
Thank you for your question.
Yeah, thank you very much for your questions. Are there any other questions? I don't see any, neither from the attendees nor from the other. But I think we're then good in time. So
Yeah.
thank you very much for your presentation.
Thank you for having us.
Thank you very much. Thank you. And now we move to the next one, fat cakey.
Yes, I will make you a presenter. Maybe you can turn on your.
Okay.
You have to turn on your microphone, please.
Okay.
Yes.
Hello.
Hey, hello.
How are you? I'm very good, thank you. Yes.
Here we are.
Good morning, everyone. I enjoyed the first presentation. My name is Oluwatoyin Onipe, and I'm the team leader for this team. And with me here is Tabia Mokele, which you can see here. So I'll jump straight into the presentation. We're talking about impact of fiber incorporation in processing conditions on development of a low-fat and high-fiber snack. And the name of our team is Fat Cakey. So I'll move straight to our presentation. Now, the objective of this study is to develop sorry for that, I'm struggling with my screen here. Is to develop a low-fat and high-fiber snack through optimization of processing conditions and ingredient formulations. And the aim of this study will be achieved through some of the objectives which we have stated here. And the first one is size reduction of the fibers we're going to be using to produce wheat flour and fiber blends, and also optimization of production process using response surface methodology and determination of the physical, texture, and nutritional profile. Also evaluation of the shelf life of the snack, as well as packaging materials. Now, some of the fibers we had in mind to use is wheat bran, and we're going to get to the product later. And the reason why we're selecting wheat bran is because it's readily accessible around here in sub-Saharan Africa, and it's rich in nutrients. As you can see, the outer layers, the allurone layer, which consists of insoluble dietary fibers, vitamins, minerals, phytic acid, lipids, and plant sterols. And also it's made up of insoluble dietary fiber. And around here, incorporation of fiber in diets is not something that most people are used to. And also it contains antioxidants, which can be of benefit to the consumers, and also contains alkylresacinolones, sterols, and sterile ferulates. And we just highlight some of the potential health benefits of wheat bran. The dietary fiber actually incorporates laxative effects, colon cancer prevention, the phenolic compounds of antioxidant properties, inhibition of low density lipoprotein oxidation, and plasma cholesterol reduction. Also, another dietary fiber we had in mind is oat bran, reason because of its accessibility around here. It is rich in beta glucans. It also lowers low blood plasma cholesterol. It improves satiety and reduces postprandial glycemic response. And it also slows down sugar and fat absorption in the bloodstream. The third fiber we look at is psyllium husk fiber. Now, this fiber is gotten from the plant seeds of Plantago ovata. It's not something that is commonly used in the product that we're about to talk about. And the reason why we've also chosen this is because it's rich in dietary fiber again. It has prebiotic properties. It improves glycemic control. It's a gentle and a natural laxative and helps with overall digestive health. It relieves constipation and diarrhea. And because it's not commonly used in fried foods, it kind of begs the point of innovation in the use of this fiber in the product we are discussing. Now, it also reduces the risk of coronary heart diseases. Now, I want to focus on wheat bran application in fried cereal snack. Now, this table shows some of the recent works from Yadav and Kim et al. In 2012 on the use of wheat bran in puri, which is a fried food from India, and donut, which is a worldwide snack. And wheat bran reduced oil by 20%, and in donut by 9.4%. And as we all know, that frying is a dehydration process, and it involves heat and mass transfer. And right now, the world is grappling with obesity. Currently, statistics shows that in sub-Saharan Africa, at least 60% of adults are either obese or overweight. And food industry around here is currently looking for innovative technologies and also food products that they can offer to consumers that are low fat and high in fiber. And the mechanism of wheat bran in fried foods, it's that it serves as a barrier that prevents migration of oil in fried foods. And also utilization of fiber in fried cereal snacks is not a common phenomenon, which we're also trying to bring to light in this research. Now to the product. The product is called Fat Cake, and that's the name for the team, Fat Cakey. It's a cereal fried dough. It's made from wheat flour, salt, sugar, yeast, and water. And the processing involves mixing. Traditionally, it's mixed manually, and the dough is somewhat of a watery consistency, and it rises, it's proofed, and it's deep fried. Now, the proofing ranges from 45 minutes to overnight, and the deep and the frying time, and it's size dependent, depends on the size of the product. So we can't say this is the exact time for deep frying generally. It's a deep fried snack. It contains about 10 to 14%, 50 grams of oil per 50 grams of product dry weight. It has low nutrients because it's basically made from wheat flour. It's energy dense. It's highly consumed. Recently, we did a survey in our locality here to see how much of this product is consumed. And from the research, from the survey, it shows that at least an average of university students consume this product at least 3 to 4 times in a week, and they can consume it as breakfast because it's ready to eat and it's a fast food. And they can also consume it as lunch, and some also have it as snack, depending on the size and the time the product is consumed. It's less researched, and that's one of the reasons why we're looking at this product, looking at the fact that people consume it a lot. So it begs for research. The local names around here is Magwinya. It's also called Vetkoek. It's called Puff Puff and Bofrot in Western Africa. Now, this is this is some of the products which we produced in the lab. On the left-hand side here is the fat cake with the fine bran. Now, because of patent intellectual property on this product, we will not be able to reveal some of the details of the nitty-gritties of some of the compositions that we use. So please bear with us on that. The product on the left is showing the crumb of the product with a fine wheat bran, which has been reduced. The size has been drastically reduced. And on the right-hand side here is the product without the wheat bran, which is the control. And that's and on the lower right-hand side is the whole product itself. It kind of resembles a fried bread or a donut. Now let's look at size reduction. Like I said, because we won't be able to reveal the particle size of this wheat bran because of intellectual property reasons. That's the coarse to the medium and to the fine. In the previous product you saw in the previous slide, the fine wheat bran was used. Now, the reason why we looked at size reduction is to combat detrimental effects of bran in dough. Some people generally don't like foods with fiber, although the world is tending towards a more healthier food option. So we said, how better can we give consumers a fiber-rich food? And we looked at reducing the particle size of the wheat bran. And it also improves the organoleptic properties of the final product as well as the nutritive value. Now, looking at the theme and the target of this competition, product formulation, that's what we're really focusing on. And a tool which we use is response surface methodology. which works on the use of mathematical models and statistics to generate optimum conditions for desired responses. And for this study, we looked at the independent variables where the addition of the bran, the fermentation, and the frying temperature were studied. Now, studies is still currently going on this product, and some people are also looking at fermentation temperature and fermentation time and frying time. And the responses which we look at diameter, the weight, volume, ash, moisture, and some other physicochemical properties, as well as consumer acceptability of the end product. Now, I won't be able to show us nitty-gritties of the results due to intellectual property concerns. So, but I'll just generalize our results using this table. The weight and the diameter product was taken. Now, because the product it doesn't have a distinct shape because of the consistency of the dough is a kind of a watery. The dough is always scooped into the oil using the hands. Based on the survey we did around, even from the commercial production point of view, it's usually produced with the hand. So we looked at the geometrical measurements, taking into consideration the packaging of the product. On the volume, sorry for that. On the volume, there was slight but no significant reduction with fine wheat bran. That means it was almost the same volume with the control sample. On the moisture, wheat bran addition significantly increased the moisture for all the particle sizes which we looked at. And also the ash, there was significant increase with wheat bran addition up to 50%. And looking at the fat reduction, we had above 50%, which was a plus for us in this project, because what we're really targeting is development of a low-fat snack, which the consumers will like and replace with the fatty, greasy product they're used to. The addedness significantly increased, but varied based on the amount of wheat bran added, which I can't reveal because of patent purposes. Also, the color, the lightness and yellowness and greenness and the LAB, significantly, there was the crust and the crumb were dark with increments in amount of wheat bran. But the darkest colors were noticed in the coarse and the medium bran, showing that the fine bran had like a much more acceptable color by the consumers. Then we'll check the fiber content. There was up to 53% increase in fiber contents at 15% of wheat bran substitution. Minerals, wheat bran increased the amount of minerals. We looked at magnesium, calcium, iron, zinc, and manganese, and it increased in that particular order. Also, using the RSM, we derived some of the model equation to predict the amount of fat content. We looked at it for all the responses, but for the sake of this presentation, I'm only showing that for the fat content. So even without going into the lab, the fat content of a particular product can be predicted using this equation by substituting the amount, the variables, which A is the wheat bran content, B is the fermentation time, and C is the frying time in this particular model equation. We also looked at consumer testing. Previously, we looked at just general consumer acceptability of the product. And also recently, currently now it's being worked upon, we're looking at doing a full in-depth descriptive studies of the new product for possible commercialization in the nearest future. For the ranking of the oiliness, the control had the highest, like the blue is showing the most oily. The control obviously was the most oily. And if we look at the FBM is the one with the fine wheat bran, MBM is the one with the medium, and CBM is the one with the coarse wheat bran. Looking at 15% addition of the bran in the product. The oiliness preference, the least oily was coarse, followed by the medium, and the control and the FBM were the last. For the shelf life study, this product is a ready-to-eat product. This is a prospective study. It's something that has not been done. But looking at the products from the commercial stores, the shelf life of the product is around 2 days. So incorporation of wheat bran, which reduces, and other fibers, which reduces fat content of the product, prospectively reduces the amount of fat, which reduces the amount of rancidity in the product, as well as the moisture in the product. So which kind of extends the shelf life of the product. It's something we're looking into. It's not been done yet. That's why we're just putting it as an addition on the study. For the packaging of the product, this is the current packaging in the market. Usually it's a ready-to-eat food. People just buy it on the go and eat it. Sometimes you can just buy it and freeze in your home and probably just warm it in the microwave later. Currently, there is cling film, wraps, paper bags, and foam plates. And our recommendations for future studies is environmentally friendly, biodegradable plates and plastics, sturdy packaging to prevent the product shape from collapsing, as well as vacuum packaging to prevent oxidative rancidity. In conclusion, realistic results were generated with wheat, oat bran, and psyllium husk fiber. However, I only gave us the results from the wheat bran for the purpose of this presentation for development of nutritious and healthier fat cakes. And however, the results generated still need to be tested on a larger scale for possible commercialization, which is something that we're looking at because of the rate at which this product is consumed around Southern Africa. So we're also looking at possible commercialization and how this product is accepted on a grand scale. But on the lower portion, on the lower scale on which we've done some of these researches, especially for the consumer acceptability, the products were fairly acceptable, although definitely people will still prefer the control. But from the results so far that we are seeing and current studies we're still doing to better improve the product, we can say that it's a success because the consumers fairly accepted the product. So this brings me to the end of my presentation. Thank you so much for having me. Future prospects, there's this system in which we're looking at, which is dry particle coating system. This image was gotten from Kim et al. 2012, which is coating, having a host particle and the guest particle. Now, the guest particle here being the fiber and the host particle being the wheat flour. So, which is coating the wheat flour in the wheat bran, which forms a composite flour, which prevents migration of oil during deep fat frying. However, we don't have this technology currently, but it's something we're possibly looking into to also develop this product and make it better than what it currently is. Thank you so much. I'll now receive questions.
Thank you very much indeed. Really interesting project. Lina, can you check if there are questions?
I'll just check. No, there are no questions from the attendees. If you have any question, please raise your hand. You can open your microphone.
I start with a question.
Okay.
Obviously, your shelf life part of this study is just actually started because you have just optimized the formulation of this product, and I'm really happy that you have been working on a local product, looking with a very scientific approach, and this is my main comment. So that was will be of a great impact. You mentioned only the aspects related to the fibers as a potential effects on the shelf life. Do you think, and also the less fat, but I mean the bran can contain also other molecules. Yes. So my suggestion is also to investigate also the role of bioactives, for instance.
Yes. Yeah,
But,
there's some of the things we're also looking at in the research group, especially looking at trying to study the fiber itself and how some of these components affect the final product. So some of these things are still currently ongoing in the research group.
I just had a comment from Pilar Moraes from Frulact. Because she has to leave, but she asked me to transmit this message to your team. She particularly enjoyed the sensitivity of addressing a local nutritional problem, which uses implementable and easy solutions and adapts and updates a current traditional product with a seemingly implementable solution.
Okay, thank you very much.
Mm-hmm.
So yeah, if there are no questions, we can move on to the next one, which is smart pastry. Use of nutritional potential of non-typical species of wheat to extend the freshness of a pastry. From Odessa National Academy of Food Technology.
Yes.
Are you here?
Yes.
I cannot see you.
I cannot see you.
Yeah, wait.
The image is frozen. Ah, okay, now it's better. Great. Uh-huh.
Can you start? Ready to present our project is using natural
It's very disturbed.
Yeah. It's not easy to hear you.
Yeah.
Okay. Oh, okay. Do you hear us now?
No, not really, not very well.
Do you have a headset maybe to connect? Or
Okay. Wait a second, please. Do you hear me? Hello?
Yes, I think it's a little bit better.
Yeah.
Okay. We start.
Great.
Our project is use of natural potential of non-typical species of wheat to extend the freshness of pastry. Considering the growing popularity of pastry, along with improving their quality, the issue of extending their shelf life becomes a actual task for the manufacturer. There are a number of solutions that contribute to the prolongation of the flow product's freshness, but most of them are associated with the usage of inorganic improved significant material costs, often are not flexible, or their use is directed only at masking, science, or styling. Considering that 75% of bakery wheat flour consists of starch, its change retrogradation are the major factor responsible for staling of their flour bakery products during storage. So starch contains often amylopectin and amylose. One of the effective ways of the problems of freshness is using the flour of non-typical species of wheat flaxseed, the starch of which doesn't contain amylose due to the major role of this polysaccharide in staling of the flour products. So the main aim is to improve quality and extend the freshness of the pastry. Is containing cakes and hot cakes based on the waxy wheat flour without using of inorganic origin improves. To achieve the aim, the following task you can see on our monitor screen. So investigation of the technological properties of waxy wheat flour shows that it has a high gassing power. Increasing the amounts of carbon dioxide during waxy wheat flour doses fermentation can be explained by a high content of the sugar. And the studies also found that the increase of waxy wheat flour mass fraction leads to increased water absorption and water building capacity of flour blends. According to the results of technological properties of waxy wheat flour and its blend with bakery wheat flour, the selection of pastry type in production of which it is advisable to use this type of flour has been justified. Waxy wheat flour has a high getting power, which can lead to the intensification of technological processes in the manufacture of pastry products, the formation of a prose structure with is caused by the process of fermentation and will help stabilize their quality. In the course of partial or complete exclusion of sugar from the recipe with require intensity of biotechnological processes in the production of the products. Also, effective results can be achieved by solving the problems of repeat staling of pastry, using in the products the waxy wheat flour, which was lower peak temperature, and its starch consists of amylopectin. This polysaccharide has higher resistance to retrogradation compared with amylose, with is an essential component of the starch of the bakery wheat flour. The cake dough, based on non-amylose flour, was characterized by a large increase in specific volume compared to the sample based on baking flour and by the increase of the phenol acidity, which is associated with intensification of fermentation of semi-finished products using waxy wheat flour. So it's found that samples with 16% waxy wheat flour were characterized with the best physical, chemical, and sensory properties. Can you see on our screen? Its usage in the production of hot cakes with reduced sugar content was accompanied in addition by the increase of the carbon dioxide among the final acidity of the semi-finished products with increased intensification of alcoholic and lactic acid fermentation process in the production. So it was determined that the combined use of waxy wheat flour with natural sweetness as powder of Jerusalem artichoke powder or amylose solubility was accompanied by the high water absorption and lower density of the hot cakes, combined with control samples based on the bakery wheat flour. The study of the quality changes of various types of pastry with waxy wheat flour during storage showed that its introduction into their recipes leads to a decrease of the staling intensity. It is important to note that the degree of crystallization for cakes crumb, which contain non-amylose wheat flour, is lower. Compared to the control with less intensive retrogradation of waxy wheat starch granules, the changes in the structure and mechanical properties of the cake crumbs were reduced a lot. The use of waxy wheat flour in the recipe of the yeast container cakes was accompanied by smaller changes. It was found that the positive influence of waxy wheat flour on the hotness of the hot cakes during their storage.
Excuse me, I'm sorry to interrupt you. Sorry, can you maybe put your microphone closer to your mouth?
Okay. Thus, based on the results of the research, it can be concluded that the replacement of bread with flour for the waxy wheat flour leads to the stabilization of the quality and enhancement of the shelf life of cakes and hot cakes without using the synthetic improves. The results of the project can be implementation of the confectionery and bakery smears with various productive capacity. It is not necessary to do additional equipment installation and technological studies for the effective implementation of the suggested development. So Thanks for your attention. Please.
Okay, good. Thank you very much. Interesting presentation, interesting project. There were some challenges that in the field of the bakery products are obviously of main importance in order to prolong the shelf life of these products. And is there any question from the participants?
No, not yet. Any of the other teams, do you have any question? You're welcome to open your microphone. No, we don't have any questions.
Okay,
Just check
anyway.
again.
Yeah.
Thanks for your attention.
Should we start with next team?
Just a moment. I would like to make a question to the participant, to the Anastasia. I wonder if what about the perception of the extended shelf life? I mean, obviously you have a different retention of the qualities and so on, but did you make any sensory test to evaluate this?
Yes, thanks for your question. We have investigated our cake, and we found that the best mass fraction which we suggest is about 60%. It leads to the highest sensory evaluation, sensory characteristics. And also we investigated our hard taps with sugar-free, based on natural sweeteners, and also they have a good quality characteristics as color and other sensory characteristics too.
Yeah.
So you can see photo of our products also.
Yeah, because I could see here, but actually, yes, this is evaluation scores based on the, it's an overall acceptability.
It's the sum of some characteristics. We pay attention for various characteristics, and then it's the sum of this analysis of that.
The average.
Yeah.
Okay. So, if there are no more questions?
No.
Just another question, because obviously here we have also as a sponsor a group on dealing with the food packaging. Do you think that it could be possible also to combine innovative packaging solutions to even further improve the quality and shelf life of these products?
Oh yeah, obviously we think about it, but we plan to find maybe partners or some consortium who are interested, who are involved in these studies, and of course it will be brought some more benefits for shelf life. Yeah, completely agree with you. But maybe it will be our next goal.
Perfect. So, ready for the next edition.
Yeah.
Okay.
There is a question from Pilar. Just open your microphone, Pilar, so you can ask.
Hello. Hi. I keep asking questions. I'm sorry.
You're welcome. You're welcome.
Congratulations on the work. I thought it was really smart at the end to add your sugar reduction challenge. So that was really smart, and it completes. It's one of the areas I think everybody's working on. You used an ingredient I've never heard about, the Jerusalem artichoke powder.
Yeah.
Can you tell us a little bit more about this?
It's the natural sweetener. It's like a potato, but it's not. It's not really potato, but it contains a high amount of inulin.
I see.
So it has a real high nutritional value, and in some products, Jerusalem artichoke powder is used as a sweetener, as a fat replacer. So it has various technological properties, and it's very popular among some researchers who are working on developing of products with high nutritional value.
I see. I'm just curious, do you make it yourself or do you buy it? Is it commercially available?
Yes, in our area, some farmers, they produce it also. They produce it, and we only buy it and use in our research projects.
Okay, thank you.
Okay, so
Thank you.
we can stop here with the smart pastry. Thank you very much.
Thanks a lot. And we invite the next team. We have some technical projects, so they followed in our computer too.
Don't worry, we manage anyway. So let's go now to the healthy crunches.
Yes,
from
Odessa
University as well. And we will be speaking with the natural ways of oxidative rancidity prevention in low moisture content bakery products. So I don't know if who is here. Maybe is
you just switched computer. Yes.
Hi.
Hi.
Yeah. You see
Here
me?
we are. Yes.
You good? Hear me?
Yeah. You can launch also your presentation.
Okay. So.
Okay. Put it in presentation.
So, hello everyone. The participation, we glad presentation our report with name Natural Ways of Oxidation Rancidity in Low Moisture Content Bakery Products. So, low moisture bakery products are classification and snacks products because of convenience, taste, nutrient, storage time, and great ability to quickly satisfy hunger on the go. It's very popular products all over the world. The profitability of the products, such type of products, considerable, exceeds the analogs indicator for bakery products. Therefore, are considered be enterprises or industry in the improving the technical and economics performance of their operation, export capacity, and improving the product's range. So, but we have problem that's fragrance occurrences of microbiology spoilage. Also, usage of artificial enhancers that have detriments effect of human height. Let's interceive tests of flour of bakery products and other. But can solve the truth. Has be can sort of antimicrobial substance with retard of prevent the growth of microorganisms that led to sport. Antioxidant based bacterial immunostimulation to nice properties. The pharmaceutical can preview products of target protective, improving their action, enhance physical preparation, and some sort of natural antioxidant biological plants, phenols, ascorbates, tocopherol, and carotenoids. So, how you can see, they have different name in other countries. Products with more low launch distribute both in post-Soviet Union countries and in the west part of Europe. They can be in the area of interesting both small and large enterprises. For example, it's Baranki, Grissini, Picos breadstick, Torare, and same how you know. So products with low monster have the following advance: can contain high level of fat, so it can be source of energy. Hand formed, crunch and floured, universal tastes and form and stay crunch for horse with toppings. Low moisture contained bakery products have before disadvantage and advantage. For disadvantage, in disadvantage is usage of artificial enhancers and synthesis preservatives, high caloric and low content of nutrients. Main part of them contain high level of sugar and salt and repeat rancidity. But after use, we have just one disadvantage. It's high caloricus. Because before in advantage we have easy to transportation, we can use that them like snack, can be extra source of carbohydrates, low term on shelf life. But after in advantage we have reduce the level of sugar and salt, be addition universal flour from herbs, usage of natural enhancers and preservation from herbs. We can use them like snack, easy to transportation, can be extra source of carbohydrates, and low time on shelf life. Today, the biggest trends in Europe is products what makes from natural raw materials. Therefore, the technologies of raw materials contain bakery products assume with of additives such as improving on oxidant action, improving on retorious action, surface active substance, enzyme modification starters, mineral salts, dry when gluten, acidification additives, and aroma and flavor additives. Now speak my colleagues is Victoria.
Hi. Purpose of the study: bakery product quality improvement by using medical herbs extracts. Determine the rational method of obtaining extracts for necessary physiological and technological properties formation. Study the effect of extract on wet flour, baking, and yeast biotechnological properties. Determine the herb's extracts antioxidative properties and efficiency of their usage in low moisture bakery goods technology to prevent oxidative spoilage. Determine the herb's extracts antimicrobiological properties and efficiency of their usage in low moisture bakery goods technology to prevent oxidative spoilage. Study the herb's extract effect on the causes of a technological process, finished product quality, their physiological properties. Use different types of fat and study their influence on velocity of rancidity. Conduct the improved technologies, industrial approbation, and develop the normative document draft. Different parts of plants are used to make extracts. Therefore, it is difficult to make common technological parameters for the production of extract. Therefore, we have developed technological instruction. For example, extract of hope. The most effective duration of extraction is 90 minutes at 100 degrees, and the mass ratio of the basic component 1 to 70 and 1 to 100. Plants there are used leaves and flowers, chamomile and nettle, for example. Extraction at a ratio mass main component 1 to 40 and 1 to 100, temperature 85 90 degree, duration 2-3 hours, stirring every 30 minutes. Plants where they are used fruits, boil for 5 minutes to soften shell, rubbing. Extraction at the mass ratio of the main components 1 to 20, 1 to 20, 1 to 40, temperature 85, 90 degree, duration 2-3 hours. Plants are used seeds, soaking and tightening in the extraction at temperature 45, 40, 50 degree for 60-40 minutes, after which when stirring the heating to 95-98 degree and infusion at a temperature of 85-90 degree for 2-3 hours. Rancidity is a term generally used to denote a condition of unpleasant odors and flowers in food resulting from deterioration in the fat or oil portion of a food. We know 3 types of rancidity. We suppose that herbs can help solve the problem with oxidative and microbial. How it can be prevented? Using inert gases in packaging, refrigeration, storing in a dark place, vacuum packaging, using antioxidant PHA, BHT. Antioxidants do not prevent oxidation, but they slow it down, terribly extending in induction period and hence the shelf life of fat-containing food. Monohydric and polyhydric phenols derivative are excellent hydrogen or electron donators, and their radicals are highly stable due to resonance delocalization. Natural cysamol, gossyphol, tocopherol, and synthetic BHT, PHA, PG. The kinetics of hope extraction have been studied, and you can see the result on slide. We care on the research about antiseptic activity of extracts, where show what can stop Bacillus subtilis. The technological characteristics were determined too. Results showed that the extract, all chosen herbs, didn't have negative effect on intensity of fermentation, tolerable acidity, ability to save the foreign of dough during fermentation. Influence of extract on shelf life, better electrical deformation, and we can see what hope not was than a BHA. What we can give: healthy product, improved quality, improved preservation, simpler process, improved rate, patent for a company. What you need: brewing machine or other equipment for extraction. It will be cost near 2,000 euro. As you can see, herbs can improve not only shelf life of product, but can have positive effect on quality and sensory characteristic of low moisture bakery product. So thank you for your attention. Good luck to all participants.
Thank you very much. Interesting study also, this one. I was just having a look at one of your slides where you showed the low moisture products, where you call one baranchi, and actually in Italy they are called taralli. They are almost the same. I mean, just to mention some notes. Okay, so questions from the participants?
Yes, from Rui Costa. He raised his hand. I'll
Great.
just open your microphone, Rui.
Hello, good morning. I enjoyed a lot your work. I think the solution, it looks simple, but very effective. But it was not clear to me how much shelf life time more is achieved using this strategy. Can you?
Thank you. Yes, thank you for a question. The normal storage period of low moisture bakery products can be up to 6 months. We don't have such time to do all research work and present these results, but we suppose that the tendency that we show in our presentation will be the same. We show only part that contain research during 2 months.
Okay. Okay, so you have no idea if it is 1 month or 2 months. So it's difficult for you to predict because you don't have enough data. Okay. Another thing is, what are the fats used? I think the fats are important.
Yes. Thank you for the question. We have only one. We predict that the type of fat will be influenced on quality and shelf life of products. So we use only one fat, but in the future we want to study this problem and use different type when we have the only one, for example, herbs extract. We plan to determine the influence of different types of fat. Now we use fat in Ukraine. We have the mixture type of fat. For example, it's like vegetable oil with animal fat, but with butter. Something it's like shortening. Something like shortening.
Okay. So still some unsaturated fatty acids that are present in that fat. So that will be vulnerable to to oxidation, right? So
Yes.
yeah, okay. Okay, thank you. I enjoyed a lot your work.
Thank you.
I have a question. If you go back to the last slide, related to the sensory properties of your I'm curious, this is a curiosity because I'm studying a lot this effect. You, I think is hop, the red ones, the red line, you see that you have a structure of porosity significantly high in respect to the control. The same also is for the structural and mechanical properties. What does it mean? Which is more hard, more, I mean, more firm? Because you have from one side the structure of porosity, which I don't know what that does mean. If it's more, if it's smaller, because this is also a question of
Not
the
understandable.
criteria.
Yes.
Sorry?
It's not understandable, yes, the results. You know, we have the special method of evaluation sensory characteristic of all our foods, different types of foods. The structure of porosity, it's the explanation of the size of pores and their dissemination in the product. So the structure of pore was was situated on the crumb, similar. And about question structure mechanical properties of crumb, we evaluate not only the finished product, we made something like semi-finished products and evaluate the structure mechanical properties of crumb, not dried bakery goods. It was like bread crumb, for example.
Okay.
Because
okay.
we didn't have any methods to measure the structure mechanical properties of crumb. It's only hardness. Yes, if you know this theme, it's only hardness we can measure in the dried and low moisture bakery products.
Okay, so thank you very much indeed. So now is time of an Italian team. So welcome, Fermente Doc, with Michela Verni. Okay. So, and the setup of biotechnological protocols to reduce vegetable waste. So,
hi.
Here we are.
Good morning, everyone. Can you see my screen?
Yeah. Put your microphone more closer to. Yeah.
Okay. Hi. So good morning, everyone. And this is Michela Verni speaking on behalf of the team Fermented Doc. And today I'm going to do a brief introduction on our team, and I'm going to illustrate the project in a way that can be clear to those who don't usually have much to do with microbiology stuff. So our team is composed by many PhD students in food science, and Mimo and Michela, which are doing their thesis here at the microbiology section of the Department of Soil Science and Food Science at the University of Bari. And they are not here right now because they're taking exams, so I hope they can be here in time. And so our main research topic concerns lactic acid bacteria, whether we talk about food fermentation or its influence on gut microbiota. And this is basically why we believe fermentation could be the solution to many problems if applied correctly and with the right starters. Now, our idea comes from the need to solve the real issue of a colleague's local farm, which is vegetable waste. Vegetables not fitting quality criteria or not sold, although still good for consumption, are a burden for farms and also a marketplace worldwide. And according to Food and Agriculture Organization, global food losses and waste is estimated to be approximately 30% of cereals, 50%, 50 to 50% of root crops, fruits and vegetables, resulting in both economic and environmental damages. And the worst part is that those vegetables are still good for consumption, and it's a paradox that in here where 15% of the population is starving in developing countries, we waste our food, which is why we want to recycle those vegetables and in extending their shelf life and creating high value added products. So if we consider all the water, hours and labor, energy for producing, transporting, and then disposing of the waste, it has been estimated that for each ton of food waste is an emission of about 2 tons of CO2. So part of the strategy proposed to deal with vegetable waste follow a biorefinery approach for nutrient recovery to produce chemicals or fabric or fuel, and they're mostly they are used for cattle feed or in the pharmaceutical industry. But the biggest part of food waste is converted in compost, which is a aerobic digestion by thermophilic microorganisms. So, however, the collection and transportation of organic waste results in high environmental impact due to the significantly larger distances. So for this reason, our project goal is to set up biotechnological protocols to recycle food waste, producing eco-friendly with high value-added products enriched in bioactive compounds from fruits, vegetables, cereals, and legumes. And as a result, economic losses will be avoided for both small and medium enterprises, creating cooperation between research facilities and industry. So this is a representation of the project, and this is how it will be developed. First, we have the selection of lactic acid bacteria for the ability to synthesize GABA, which is a neurotransmitter of the central nervous system with antihypertensive properties. And then we'll select them for the ability to produce B12 vitamin, which is, we don't know what it is, but it's lacking in the vegan diet, or to release bioactive protein peptides to improve antioxidant activity and to exert probiotic effects on human body. Then we'll have the fermentation of the wasted vegetables to obtain functional foods. And this product will be stock cubes fortified with GABA, bioactive peptides, and B12 vitamin, or yogurt-like beverages enriched with antioxidant compounds, vitamins, and probiotics. The biotechnology itself is rather simple. The challenging part is the selection of lactic acid bacteria for the ability to accept the necessary functions. However, the idea is supported by plenty of studies carried by the scientific community over the years, and the next few slides show how an overview of the potential of lactic acid bacteria as a proof to the feasibility of our project. So lactic acid bacteria have specific proteinase peptidase activities able to hydrolyze proteins, releasing bioactive peptides known for many physiological functions. And that could be hypertensive, antioxidant, anti-carcinogenic, antimicrobial, and well. So fermentation with selected lactic acid bacteria used alone or in pool was successfully used to release antipertensive peptides or antioxidants from different vegetable matrices, including wholemeal wheat, quinoa, spelt rye, kamut, navy bean, soybean products. And although cereals are and legumes are the main target of research topic, bioactive peptides were released through fermentation also over other vegetable matrices. There are also multiple studies on cereals, pseudo-cereals, legumes, and fruit with fermented with lactic acid bacteria and enriched in not only bioactive peptides but also GABA. And also, few lactic acid bacteria are capable of encoding the biosynthesis pathway of vitamin B12 and also other vitamins, not only B12. And these features was demonstrated not only in vitro but also in situ with in food, soybean based food. Moreover, multiple evidence confirm the ability of lactic acid bacteria to improve antioxidant activity due to the release of antioxidant peptides, but also phenolic compounds or the presence of enzymes that degrade superoxides. This ability was proven to be effective on vegetable matrices. In other cases, the metabolic end product of phenolic degradation by some lactic acid bacteria exerts human health benefits. So the last feature we'll be addressing lactic acid bacteria is their probiotic effect, which is the result of a series of abilities. First of all, the ability to arrive alive and in identity in the intestine, and then competing with all the bad bacteria we have and exerting their physiological function. Now, it's easy for us because we do this every day, but only this example might seem theoretical to those who are not microbiologists. So I added this slide which shows how do we actually select bacteria. So we first isolate them from food, then when we are sure they're pure culture, we extract DNA and we identified at species level. Then we select, that's when that's when the selection actually begins. We test them from all the above cited characteristics and then we chose the representative ones which are the best performing strains. So after the screening and the selection of the appropriate lactic acid bacteria, it is necessary to test in situ the production of all these functional compounds, and each vegetable matrix should be singly fermented chemically and nutritionally and characterized to assess their potential functionality. This is the production of stock cubes, and in this case, the technology will have some variation between the conventional and the innovative one, because the existing technology consists in a complete hydrolysis with the hydrochloric acid, followed by an neutralization, which consists with sodium carbonate, and the stock cube on the market are made mostly of salt, which is more than 50%, flavoring and other ingredients. And vegetables represent a very small part of the formulation, less than 1%. On the contrary, our product will be entirely made of vegetables, since biological acidification will not provide the same level of hydrolysis, reaching higher pH level than those obtained with the conventional process, and the amount of sodium salt formed during the neutralization will be markedly lower. Now, moreover, there will be organic acids, small peptides, and amino acids that will contribute to the final product flavor. Now, the production of yogurt-like beverages only requires the setup of the fermentation protocol, and the resulted enriched product can be safely stored at refrigerated temperature. Otherwise, we'll have to before the fermentation to do something with the matrix, like pasteurization or blanching or something. So our smart recycling process will avoid economic losses for businesses that could sell their waste to bigger company or deal with it on their own, since biotechnology behind is really simple, and the innovative biotransformation of vegetables waste proposed will provide a wide applicability in a variety of food chains and a high commercial uptake. So the substitution of chemical hydrolysis with a biological one in the production of stock cubes is a less expensive, eco-friendlier, and healthier option. And the increasing vegan population pushes food industry to adapt to not only what they want, but also what they need for a balanced diet. So the lack of a particular component introduced, especially from animal sources, requires food industry to come up with new ideas, and fermented vegetables enriched in vitamins and antioxidants is one of the ideas. And moreover, the attention of consumers towards the benefits deriving from antioxidant assumptions makes fortified beverages particularly appealing to a large segment of the market. And fermentation is one of the best ways to preserve the shelf life of the food category otherwise wasted, while improving its nutritional and functional properties. So that's it.
Thank you very much, Michaela. Interesting presentation and project. Questions from the participants?
No, there are no questions. Yes, no. Rui again, I will open your microphone.
Hello.
Hi.
I think your project is very interesting, but I have one main doubt. How it will be the taste, for example, and of course you can always ferment that. If something is missing or a substrate is missing, maybe you can add it, so like sugar or whatever, to make that the fermentation. But then, how are you going to keep a constant product? Are you going to do, for example, fermentation just of carrots and just of apples, and then
that's the idea, to ferment singly.
Yeah, isolated.
Because well, first of all, the fermentation needs to be carried on with the selected lactic acid bacteria, not spontaneously, because only in that way we can control precisely which are the compounds produced at each step of the process. Because if we don't use selected lactic acid bacteria, we ferment with the natural autochthonous bacteria, we cannot guarantee the same standardized product. So once we ferment, the sensory analysis is included. Of course, that's not the first, that's the last thing we do, but it's the first thing to make sure the product is accepted by consumers. And if that doesn't work, if the product is not good sensory, we cannot do the rest. So they are all these criteria are taken together in the.
Okay. And what are the main targeted vegetables you want to reuse or recycle?
Well, which vegetables I want to recycle?
Yes. Yeah, because you have many vegetables. I'm sure it's impossible to do a fermentation of 20, 30, or 40 vegetables. So
Sure.
probably just to focus on one or another.
Sure. Well, depends on the final product, but surely for soft cubes it will be the common vegetables used. So carrots, onions, and maybe other vegetables common here like beets or zucchini or others, and the ones usually used. Well, with the yogurt-like beverages will be more like a fruit-type vegetables, and well, maybe not in this case, but in the case of the stock cubes, will be the potential addition of legumes just to improve the protein content and the release of bioactive peptides could be considered, because maybe carrots and onions, they don't contain enough proteins, and it's clear, as I said before, each should be singly fermented, and then the things put together.
Okay, thank you.
I have just one small question. As the main topic of the competition this year was focused on shelf life, what does it mean, this project within this main topic? Because actually...
Yeah. Okay. The shelf life, as we see it, is in this case is not improved from the product. What I mean is, it's not like bread, and we are increasing its shelf life from 10 days to 12 days or to 2 months. It's different, but vegetable waste, which we consider are still good, which means they could be used, but every day they get thrown away just because they are not sold, or because they have something that prevents them from people from buying them, or the industry to use them. So they're still good. So that's the way to enhance shelf life, because we avoid them to be wasted, even though they're good.
Yeah, now I understood. Yeah, yes. Now, because actually during in your presentation, this aspect was not obviously below, looking at more in a wider perspective. Yes, maybe one slide could be really being useful to better clarify this aspect within the main topic of the. So just to complete your presentation. So, but anyway, very, very well done. Okay, so if we have not any more questions, so we move to food C, maybe, from Cyprus University of Technology, with the project title Strengthening and Promoting Short Food Supply Chains and Local Food Systems by Menelaos. Are you here? Okay, hello. Great.
Can you see us?
Yes.
Hello. Give us a moment, please.
Okay. When you like, you can start.
Okay.
Hello everyone, we are Food CY team from Cyprus. Greetings from the beautiful old downtown of Limassol city. My name is Triana and here is Menelaos. Unfortunately, due to professional obligations, Anna and Zenonas couldn't be able to be here today. So we will present you our idea, which is evolution of food supply chain throughout primary production by innovation. In this presentation, the headlines which we'll discuss are the problem statement, project strategy, innovation, potential applicability, and benefits in respect to the state of the art. And this is a framework, shows the overall principle and ideas. The general problem that it was identified is a difficulty adjustment of the overall food supply system. Its adaptation is needed because it needed to both increase the productivity and decrease the environmental impact. Because of its extended scale, the limitation of its participants or knowledge accessibility and their biodiversity, it makes it possible to holistically adapt fast enough. Although major activities have been made, their implementation is too complicated. For example, the establishment of the United Nations Sustainable Development Goals and their implementation program consider as fact that different governments will apply the same policies and there will be a clear collaboration between public sector, private sector, and independent institutions. It is as complicated as the problem itself. Furthermore, despite the legal efforts by establishing laws for fair trade practices and food safety, it considers as a fact the mutual cooperation understanding. Unfortunately, this is not realistic because of the dependency high in dynamics participants have created smaller dynamics participants. The more specific problem that the project is focusing is that most pressure of the situation is bear by farmers, combined with the lack of technological literacy and standardization and quality characteristics of primary production commodities is making the next generation to big turn of the profession. There is a vital need for adaptation, not just for their development, but the profession's very existence. So, with this problem statement, we propose to solve this problem by creating an innovative business-to-business web-based platform. The project is composed by the strategy of project development, objectives, and the development of the project. And let's start with the strategy of project development. First of all, there is a big gap on standardization of quality characteristics and use of primary production commodities between farmers and other chain participants. This leads to lack of holistic food waste and management and restrictions on sustainability of food supply chain. Also, application of unfair trading practices against farmers and the extended number of intermediates between farmers and consumers. This leads to increases their cost structure and shredding their profit margin. Inevitably causes shredding of the overall agricultural sector. Integrating approach to the problem can only be achieved by involving actions from the public, private sector, and independent academic institutions. Solution is to adapt the principle of shared food supply chain to minimize the distance between consumers and farmer suppliers with farmers. It's recommended, to create a business-to-business network to boost farmers' productivity, incomes, and acknowledgement. But every action has its restrictions. In business-to-business approach, there is a lack of control on relations outside network. It can be offered a regulating interdisciplinary control on deals. Objectives are separate on short-term, mid-term, and long-term objectives. Let's start with short-term. Includes reducing the food and input wastes, unfair trading practices, and the stability of quality characteristics. Also, giving farmers accessibility to a wider range of partners and to a wider range of knowledge. Also, reducing the distance between farmers and consumers. Mid-term objectives includes creating a network capable to boost the evolution of the supply chain, upgrading farmers' social status, and building up peer-to-peer relations between farmers and reducing the farmers' cost structure. Finally, the most important objective, the most time needed, and the most difficult to success are the long-term objectives, which includes eliminating unfair trading practices, total stability of quality characteristics, and ensure economic, social, and cultural independence of farmers.
Sì, buongiorno, sono Paola.
Excuse me?
You can continue.
Thank you. So, hi, I will present you how we are planning to develop our project. First of all, we use the business model canvas commonly used in entrepreneurship to properly describe our business idea. The blue color boxes concerns the element to create value for the project. The green color boxes concerns the element to distribute its value, and the red color boxes concerns the element to capture its value. In the right corner, firstly, in the right corner, the customer segmentation, which are the customer target segment, are mainly professional and part-time farmers. But the most crucial target segment is the next generation of farmers because they are better technologically awareness. They have the resources to start a new agri-food business, probably headed from their parents, and a totally innovative mindset. In the center, the value proposition is basically what we promise to offer to our future customers. We have separated in 6 sub-values in order to understand it better. Firstly, we will offer an on-demand production because it's commonly seen in Cyprus to firstly produce it and then negotiate to sell it. And this leads to unnecessary waste. Secondly, we promise to offer allocation of resources and knowledge by offering a wider accessibility to partners and suppliers. Accessibility to new services for electricity, for water, for human resources and equipment. Thirdly, we will offer economic independency, again with a wider accessibility to partner suppliers, by cultivating competitiveness among them. Fourthly, the core sub-value of our value proposition is the elimination of unfair trade practices. Firstly, by the wider accessibility to partner suppliers and by contract-based deals with specific parameters between the external partners and our clients, our farmers. Fifthly, we will promise to offer a social contribution recognition to the farmers by encouraging them, giving a merit of their primary food production to social grocery stores, which for free products for the vulnerable parts of our society. Those food commodities will have lower market standards, and in case of oversupply. Lastly, we will promise to offer a real-time service to keep our customers satisfied and to ensure regulatory monitoring and control. As for the key partners, we separated them in internal, external, and passive. Internal are the core team of our business because it will create the value through the interdisciplinary approach. After that, the external partners are the common partners of the farmers, or they should be the common partners of the farmers. And lastly, the passive partners and contributors of the overall food supply chain with big influence, like the public sector with ultimate legal force, and the Airbnb, where there are a lot of people. They want to meet rural communities and the rural people to meet the authentic side of Cyprus. As for the key procedures, the biggest part of them are concerned the deals will be implemented through our web-based platform, and the smaller part concerns only the internal part of the business. Firstly, the external partner will make the offer to provide its services or its product, and we will set a price setting as for the specific quality standards they set. After that, a cross-talk negotiation between external farmers and our clients, our external partners and our clients, the farmers, will be made end with the deal making contract signature between them. Till the end of the deal, we promise to give regulatory monitoring and control on every parameter it was contracted. Also, as for our procedures, we'll need to have some marketing practices to share and create the value to the market, and every payment has to be made via PayPal in order to be checked properly. As for the key resources, it's a common resources they use in every business, usually in every business. First of all, human resources, which are basically the internal partners and the founding team. It's a most vital part of our business idea. Secondly, web-based platform, which is our tool to implement it, and Office, which commonly used to contact with other people. After that, the customer relationship will be based on, as we said before, business-to-business approach. It could be provided an automated services relationship in order to avoid waste of time, and we offer long-term relationship in order to keep up with the new potentials. As for the channels, we separate them in information, triability, purchasing, and distribution. Firstly, the information channels will be the personal contact, word of mouth, web-based platform, and social media. As for the triability, will be also with personal contact cooperative, which is a great source, of partners and external partners. As for the purchasing, it will be used web-based platform and personal contact. Lastly, for the distribution will be made via internet. As for the cost structure, is commonly used is the staff and internal parts wages, advertising and marketing expenses, and some office expenses. Lastly, the review streams will be an entrance fee both for our clients, the partners and external partners, a commission of every deal. It will be probably 5%, but it's still questionable, and a premium promotion of external partners in order to be higher to the risk to the success of our clients. As how the actual plan will implement, we'll create 1 year round Gantt chart. First of all, the market research will need approximately 1 month to implement with partner research and customer research. After that, an accelerated training of founding team internal partner will continue another month for basic tasks. And at the same time, the design of the web-based platform will start. After this period of time, 1 additional month will needed to evaluate, to make the feedback of the design, and at the same time we will start the creation of web-based platform, which will need about 3 months according to some professionals. At the last month of the creation of web-based platform, we'll start the functionality testing and performance indicator evaluation, and the total review update of the project. It will need 1 month for the first one and 2 months for the second one. If everything is okay, if the numbers are okay, we'll proceed to introduction to market and application of marketing tactics for the following 6 months. The last month of the action plan will be made another functionality testing to see if everything is again okay to implement our future action plans.
So, the innovation naturally comes from an innovation idea and its commercial exploitation. At the first time that this innovation idea was an extract of systematic research on Cyprus food supply chain. In the meantime, it was discovered that the same challenges are globally found. After that, the idea was organized to meet the commercial exploitation regardless of the country in order to maximize its applicability. Its competitive advantage compared to other similar efforts is the fact that it's focusing to create a more flexible network where every participant can thrive instead to promote a disrupt approach. Those approaches are causing shock to the system and easily rejected because of the nature of the agri-food system. In conclusion, we are glad to hear your question and we will try to answer them. Thank you for your attention.
Thank you very much. Sorry. Thank you very much. Sorry for before I received a phone call and I had the microphone on. Interesting approach. Any question from the participants?
Yes, from Rui again.
Rui.
Hello.
Plenty of questions. Thank you very much.
I think this is a very interesting approach, and nowadays the food chain needs more and more these approaches, complex, that involve all the stakeholders, and so and they have a food system view. But the topic of this competition is shelf life, and I noticed in your documentation that you didn't use that word once. So where you didn't, how do you relate your objectives, your strategy to improving shelf life of food products?
Can you repeat the question, please?
So the topic of this competition is to extend shelf life. How is your project related with this objective?
It's not just to extend the shelf life, it's to find a problem in the food industry and to solve it, right?
Mm-hmm. Okay.
So propose this to reduce from the one side the instability of quality standards and the unfair trade practices.
Okay.
Mm-hmm.
Okay, thank you.
Okay. Thank you very much. If there are no questions.
No questions. Maybe from the other teams. There are any questions? Or the panelists?
No.
No.
Okay, we have already seen for a few seconds the Imagineers on the background here.
Yes.
Imagineers, innovative solution to extend the shelf life of button mushrooms. That's an interesting team. I think
please turn on your microphone. Sorry, Paula. You have to turn on your microphone.
The microphone. On.
Yes. Hello.
Okay, great. Well done.
Yeah.
Hello. Hello. That's an international team, and I'm very happy that you took this opportunity to make a team for this project. So
we would also like to thank all the organizers for being generous in giving us the opportunity to participate.
Yes, and arrange a nice competition for students.
Yes.
Thank you very much. Thank you very much. And so, but now we have to see your project. So,
So shall we proceed? Shall we proceed?
Yes, please show your presentation.
Yeah. Now, is my screen visible?
No.
No.
You have to accept to share the screen.
Where?
I'll try again. I give you the presenter control now. You should receive a.
You can give me.
Here.
Show my screen.
Yeah.
Great. Well done.
Perfect.
Is it fine?
Yes, Onkar, you can go on.
Okay.
Okay. So
I will begin with. So our objective is to Wait a second. Our objective is to propose innovative solutions to extend shelf life of button mushrooms. And we are Team Imagineers. I am Onkar Pratik. To the left of me is Joholondri, and on the right of me is Chuni Yan. Unfortunately, Sarah has to work today, so she couldn't attend the seminar today. So we are 3 right now. And we are in our guide was Dr. Lars Nilsson. He's the associate professor in Lund University. So the objective is to enhance the shelf life of button mushrooms to 2 weeks in supermarket. In addition, we are proposing to have a better visual appearance of the mushrooms that are acceptable to the consumers. So before proposing this idea, we did a lot of consumer survey and market study, and we found that this is a prevalent problem that the market is facing, especially in Europe. So as you also said that we are quite an international group, we all face this not only in Europe, but also in our own country. And every time in 1 or 2 days, the mushrooms started to lose its visual appearance, and then the sensory aspect used to deteriorate, and consumer didn't like the aspect. And this is because of the tyrosinase, the enzymatic activity that is quite high in mushrooms, and also due to the respiration, high rate of respiration. As we can see, the oxidation of the enzyme leads to browning color, and further accelerates and catalyzes other enzymatic reactions. There is also a study which says that the microbiologically the mushrooms may be good, but sensorily wise its acceptability is reducing, and this is leading to a lot of food waste. So our objective is to counter that. So as we said, the present scenario is due to the incomplete sales because of the large waste and shortage of mushrooms. This leads to decrease in the sales and the gross profit of the suppliers. The shelf life is also an aspect that leads to the increased wastage, and the consumer preference. As I already mentioned, the mushroom may be microbiologically safe, but consumer discard because of the visual appearance. But this is the present scenario, as we already talked. This is because of the moisture, the condensation of the droplets outside the packaging leads to these changes. The high rate of respiration also accelerates the spoilage, and there is no robust solution as presently offered by the industries. And these all in combination are posing threat to food safety. So this is our solutions that we thought after a lot of research studies and discussion with the experts. So first and foremost, in industry, we are looking forward to a very structured set of solution. The first is by first in, first out, and tagging of all the mushrooms that we receive after the sorting and the grading. So the mushrooms that are geometrically acceptable, we just give a tag to it, and the first in, first out, and the tagging system ensures traceability. Then we are going for the irradiation of 1 kg gray, the 1 kilo gray, which leads to the destruction of all the surface microbiota. Then we are proposing 2 set of coating. The first set of coating is the oil coating, that is cinnamaldehyde and thymol oil, which the studies have shown the antioxidant benefit of these coating. Then we are proposing a chitosan and citrus fiber coating, which has these polysaccharide coating, reduces the rate of respiration as well as provide a robust barrier against the microbial attack. Then we are proposing the third barrier is the packaging innovation, which we are stating is the sorbital coating in the packaging, as well as ventilation with 100% oxygen packaging. This is our modified atmosphere packaging solution. This is already I have explained that the first set is the first in, first out, what we were because of the better traceability system. The UV ray studies, the UVC pre-treatment, which destroys the surface microbiota and ensures the shelf life of mushroom is enhanced. It also leads to the slowing down of the enzymatic browning. And then we are going for the UV. These equipment have shown that this can be escalated to the industrially quite feasible and can be carried continuously. And the further slides will be taken by Chuni Yan.
Well, when it comes to oil fermentation, we do some research, and also we do some trials to prove the research, and we found that cinnamaldehyde and thyme oil combination can help to reduce the enzyme activity as much as they can. And then the browning appearance will be controlled efficiently. Also, we search the equipment since the competition is for factory. So we chase for industrial feasibility, and we found some equipment like this. Also, it can offer the continuous processing.
Then we further formulated a layer of packaging, just like layer of coating, because for the trials which we did in our own laboratory scale was we couldn't go for the 2 layers, but in simultaneously we went for the citrus fiber and the thyme oil coating. But we are proposing in industry that chitosan and citrus fiber can have synergistic benefit as supported by the research paper, which we have well documented in the report that we submitted. So the chitosan coatings are generally good barriers, and they, as I already said, these adhere well to the surface of fruits and vegetables, and mushrooms can be very effective to this solution. And all these coatings are also quite sustainable. So we are focusing on another pillar is sustainability. Whatever we are proposing is not just a threat to the consumers, because all these are not as numbers, but more like sustainable ingredients, which gives a good sense of marketing view as well, but also reduces your overall carbon footprint. This is the fiber emulsions that we prepared in different ratios. These on the right side of the screen is the 2 different set of fibers solution that we made. It was like the fiber was lipophilic, so we had to solubilize it in a bit of oil is to water. So we made an emulsion with this, and as already mentioned, the thyme and the cinnamaldehyde oil was used to solubilize, and then we further diluted it with water, and a phase inversion was reached. So sorry, so this is what we did. So then we moved on to, then we are further justifying our thing that just like in chocolate factory, the coating solution, the coating or the enrobing process is very important. We can also say that a very dilute or thin layer of coating can be quite effective for mushrooms. So we are proposing that this machine, which is used for coating, can have a very effective solution that we are proposing, because the viscosity of chitosan and citrus fiber is quite similar to that of chocolate, and the machine can respond quite well to this. Then we are proposing a change the packaging, which because we want to offer a complete 100% thing, because any loophole in the whole system can lead to the shelf life reduction, which we don't want, because our main aim is to reduce the food wastage and enhance the shelf life without reducing the acceptability amongst the consumers. As mushroom has a lot of health benefit and also high protein content, it is always at the risk of proteolytic enzymes and bacteria. So we think like after the series of coatings and the pre-treatments, the packaging is an important aspect. So the sorbitol has quite a moisture scavenging role, which is well known to everyone, and it ensures a stable RH inside the packaging. So this is what we are proposing, and the respiration can also be controlled if we change the overall gas content or the carbon dioxide to oxygen ratio. So we thought that carbon dioxide can lead to a lot of cap opening in mushroom, and it is not desired. So and a lot of high oxygen also leads to a lot of issues with respiration. But then we did a lot of scientific study and literature study, which we found that high oxygen, like 100% oxygen in the packaging, leads to a very stable presence of mushroom inside, and the shelf life can be enhanced over 2 weeks. So this is the modified atmospheric packaging equipment that we want to decrease the we want to control the overall respiration, and this is what we are proposing, so that the mushroom colors and the shelf life doesn't deteriorate during its life cycle. So we carried the sensory analysis, and which Joholondri will explain further.
Indeed. So I'm happy to guide you to the sensory apartment of our study. So we did the sensory, where we worked with the coating, and we had three samples, of which we had the control, the normal mushroom. We had coating 1. The coating 1 was the C35FG with the mixture of cinnamon aldehyde and thymol oil to make the emulsion, as explained by Onkar. And the sample 2 was the Citrify M40 with the mixture of cinnamaldehyde and the thymol, also indeed to make an emulsion. So after the first day, as you can see on the slide, the appearance of the control was still better than the others, but this mainly is because of the physical appearance of the coating. But then if we continue after 4 days and 8 days, we see that both the controls, both the coatings had a remarkable effect on both the shape and the texture for the mushrooms, which is rather beneficial, and that shows that that our sensory panel also agrees with the goal that we want to increase the shelf life and thus reduce the food wastage. So as a conclusion, we can say that what we try to achieve is kind of how do you say, confirmed by our sensory panel. So then, if we want to sum up, we have we would like to emphasize on the advantages that we are targeting. So we have a low enzyme activity and also the browning due to an antioxidant activity, and of course also because of the UVC radiation. Then, of course, we also have the reduction in the cap formation by the coating process, as we explained earlier. Then there's no moisture accumulation by action of the sorbitol. And also with the FIFO system, first in, first out, we really are also targeting the traceability system. In general, we have an improved visual appearance. We also have an improved taste by the phenolics incorporation, as we said. And then in general, also the enhanced shelf life by countering the microorganisms and the growth of them. So in general, what we wanted to target and what we think we achieved is reduction in waste from the supermarket by increasing the shelf lives of the mushrooms. And if we then have a look at the innovation, the SWOT analysis, so we have the SWOT, which means strengths, weaknesses, opportunities, and threats. And this gives a clear view of what your idea or proposition is about. So let's maybe first start with the strengths. So as I said earlier, we have an enhanced shelf life. Then also, due to this enhanced shelf life, we can emphasize on the better sensorial properties that we are creating. And also, as we are working with the fibers, we are reducing the chemical processes, and we are emphasizing on sustainable and green processes. Then, of course, there are some threats on the market that we are hindered from the management of the companies to implement changes, because as for now, it's a rather cheap process, but they are not really emphasizing on the important thing of reducing the food waste. And then opportunities are that we have an increased, this is really known and gets known by the consumers, and they really appreciate this solution, which makes maybe an increased sale of mushrooms. And thus, again, we are possibly reducing the food wastage once the consumers are introduced to our opportunities. And then we are also strengthening the food safety system by incorporating our fibers. And we have some weaknesses. As we said, it's more expensive for now than the current production method and shelf life method, though we are emphasizing on reduced food wastage and increased microbial safety, and on low throughput. This is yet a working point, but we are looking and working together here with the University in Lund to find a more appropriate solution to to really be feasible in industrial sites. So I think we came to the end of our presentation. We would like to thank you for your attention, and we hope you enjoyed it. Thank you very much.
Thank you very much. Great. Well done.
Thank you.
Okay, here I am.
Yeah.
Any question from the participants?
Yes, one of the teams, the Fresh Wind of Food Changes. They have a
Okay,
question. You
great.
can just open your microphone.
Hello again.
Hello.
Hello.
So I have a question about your packaging film. You said that you have like a nano packaging. Why are you calling this nano? Like exactly as a packaging film nano? Do you?
So it's hello.
The question was why nano? Why?
Yeah.
Yes.
Yeah. Why nano? Why nano packaging film?
Yeah,
Why
it's
are you
like
calling?
it's like because we are trying to place a coat of, as you mentioned, as you paid attention, the sorbitol coating that we are putting on the packaging. It needs to bind to the packaging material and be a coherent system to all together. And the research studies have shown the sorbitol nano gels along with the packaging is quite robust and provide a very tangible solution at the end of the day when you look. So our sole motto is to ensure that the packaging in the sorbitol becomes a whole together one system rather than being a different separate system. And as you know, the nanocrystals or the nanogels have been quite efficient in also not only just with the normal packaging but also with the bio-based packaging system as well. So in that regard, we are proposing that solution.
All right.
That answers your question?
Yeah. Thank you.
You're welcome.
Thank you for the question.
Yeah.
Thank you.
Can you hear me?
Yeah. Who is there?
Hello.
Yeah.
Hello.
Hello. I have a couple of questions. Can I speak now or later?
Yes.
Yeah,
I think so,
Yes,
yeah.
you can speak. It's
Okay. So first of all, my warm congratulations because I found your report well written and the project really well organized. So congratulations for your work.
Thank you so much.
Thank you very much.
I would like to talk a little bit with you about permeability because to package a fresh food in 100% of oxygen atmosphere, I think is a quite critical step of your process.
Indeed.
At first, it is a little dangerous to use oxygen at such high level of concentration.
Yes.
But for sure, one more problem is related to the barrier that you want to use to maintain this concentration of oxygen inside the package. Did you face this problem? Did you already choose the barrier material that you will use for packaging the mushroom?
First of all, thank you for throwing light on this aspect. Actually, we went through a lot of study references, and as you can see, China is one of the major consumers of button mushrooms.
Yes.
And there were a lot of research papers as well. And the Chuni, who comes from a region in China which also faces the same problem. So we had a discussion on this, and we talked to a lot of professors, and because we were also a bit considerate that whether 100% oxygen does look, whether it's a very feasible or a very, what to say, acceptable solution, or is it just a bit too risky?
Too technical.
Yeah, too technical. But then we went through a lot of literature studies, and we found that there have been research conducted over it, and they have found a very strong reasons that this is the best possible solution that can help in enhancing the shelf life of button mushrooms. Especially, it may not be the best suited to other fruits or vegetables, but yes, for mushrooms, it has shown good potential results.
Indeed.
Yeah.
Yes, higher oxygen content will decrease the respiration effect, and then it can extend the shelf life for mushroom, especially for button mushroom.
Yeah, my question was also on the packaging material that you plan to use for your new form of packaging of mushroom, because if you have 100% of oxygen inside, you need a very high barrier to maintain that concentration. Did you already choose the barrier material for your application?
No, right now we were like a bit because we were thinking of using first. We did as I said in the beginning of the slide, that we did a consumer survey in the research paper where they used this 100%. They did a glass. They used a glass carrier, a glass box. But in Europe, you never see any mushroom or vegetables in a glass box or
It's always
can.
plastic.
It's always plastic with a transparent film or something. So our biggest challenge is to ensure that the solution stays intact with that, because the consumers are not willing to try something new or something quite different. Although glass can offer us something, you can always put it back to the supermarket, but consumers are always not welcoming to these new changes. So that's the trick. And the second thing is, like, when we are saying that there is a coating of sorbitol or the coating, we wanted to make the transparent film a bit thicker that can withstand the 100% oxygen concentration inside the box. So this is what we are thinking, and we talked, and I think all the things that we are proposing has to be a bit in balance between the research as well as the consumer acceptability
and the feasibility of bringing it on the industrial market, that consumers, as Onkar says, that
but you can find also flexible packaging material which are barrier enough to maintain the modified atmosphere that you have chosen for a long time. The question was exactly which kind of material, because normally these barrier material are expensive, are not very easy to find out, and that was my curiosity. And
that's
if I have time, Paula, I would like to ask one more question, because
sure.
I found a little contradictory to use 100% of oxygen inside in order to modulate the respiration rate of a mushroom. And
we have
at the same time, you use chitosan, which is a very high barrier for gas exchange, as a coating of a mushroom. Did you investigate the barrier performance of your coating? How big is the permeability of oxygen and carbon dioxide of your coatings? Did you get the question?
Yes, we got the question. You were saying that the 100% oxygen and the exchange of gases with coating of chitosan are a bit contradictory.
A little contradictory, because you put a very high barrier around the product and a lot of oxygen outside, which is expensive, which is critical, which is somehow a very interesting idea, for sure, proved by many researchers, but a little unusual, I can say, no?
Yes.
So maybe a lower concentration of oxygen and a thinner coatings around your product could work in the same way. Just to provoke your reaction, you know?
No, you are quite right.
What kind of
actually you're quite right, because even though when you write any scientific reports or something, as I also said, like 100% oxygen, don't you think it's a bit too unusual or unrealistic? But then, as we say that we justified it by also in the reference section we have put those papers, but there is a relevance of the 100% oxygen because it augurs quite well with the button mushroom. And with the chitosan and the citrify coating that we are proposing, the citrify, it's like a kind of a polysaccharide gel.
Yes.
Not, I will say a gel, but it just coats. It's an emulsion that puts a very thin coating. We are not
thin layer.
Very thin layer, and the concentration of the chitosan is also, as mentioned in the report, it's less than 1%. So
how thick is the coating? Sorry, how thick? How many microns? The thickness of your coating?
That
that we haven't measured the coating. It's just like a sprinkle that we have put in. Because
the size of the coating in microns we can't really answer because
right now, because we haven't measured that. But in industry, it's just like we propose like.
But we could do the experiment again and then measure the coating, and then we could come back on that regard, because now we can't give the answers that you want to hear. So.
But I think it's a good suggestion that you mentioned, because we as a technologists and scientists needs to understand, and because this is a real market problem, and it's good that we are having a base or a platform for discussion, at least on this.
Yes.
Okay. Thanks a lot. Thanks a lot.
Thank you.
Thank you very much for your question.
Thank you very much for the
Thank
question.
you for the attention.
Thank you very much. So all the team of Imagineers could test the skills and expertise of Professor Luciano Piergiovanni on food packaging and shelf life. So he was really a good evaluator of all the projects from this point of view. Thank you very much, Luciano. Okay, so now is again my time, but it's also the time of all. So Line, please give me the screen.
Yes.
So I go now to the final part, which is the most important one, my dears, all, because you have been working a lot in these months, and we have actually could see your projects. I have to say, all of them with really interesting hints, innovation aspects related to the sustainability, and for sure aimed to solve problems of the modern industry, also taking into account main issues that nowadays the food value chain is facing. But the main aspect of this competition is the fact that at the end there will be some winners. So actually we have been working let's say behind the teams, trying from one side to advise them and give some hints by also the webinars, and on the other side by giving some main contributions and the guidelines. The awards, we have been collaborating in tight connection with the two main associations, the ISEKI-Food Association and the Italian Scientific Group of Food Packaging, that gave us the availability of 2 awards with the money. From this point of view, we have 500 euros for the best project dealing with innovative packaging, distribution and logistics, sponsored by Jessica, and here represented by Luciano Piergiovanni, and an award of 500 euros for the best project dealing with innovative process and formulation actions to enhance shelf life, sponsored by the ISEKI-Food Association, here represented by Gerhard Schleining and also myself, and I think that both are here with us. Some pictures of this morning. So I've taken, so while you was giving the presentations, I was also taking some screenshots to remind the very good time we have been having together this morning. This is one part, this is another part. You can see that actually I've taken at least one from each of you. Awards, but also certificates. I mean, the 7 groups teams that finalized the competition by submitting the report and the reports will receive all certification of attendance and participation. And besides this, the winner team will also receive the corresponding winner's certificate. All the process and the competition, as you know, has been supported by the scientific committee here reported, and the final evaluation was also supported by external and additional evaluators, as already mentioned this morning. The projects have been evaluated by using some criteria, taking into account the fact that the projects were also focusing on the main topic of the suggested for this edition, that was shelf life. And besides this, innovation, potential applications, potential benefits, the report, also the quality of the strategy and development, and the presentation and the report in general, the quality as main criteria. Here are the list of the candidates teams. Here are the screenshots of the first slide of each of your presentation. Here you have already, you can see and you will receive by email the certificates of attendance of all the 7 teams, as you will receive. But now is the time of announcing the winners. So I also would like to start with the first one, which will be the winner team and project that will receive the sponsored award by Jessica. And I would like to activate already also Luciano. And it's the time to announce it. I hope that you all are ready. So let's go to the next slide. And the winner is Imagineers, with the innovative solutions to extend the shelf life of button mushrooms. I don't know if Luciano will say something more.
Oh, just that it is a real pleasure to nominate for the FoodFactory for Us award, sponsored by GSICA, which is the Italian Scientific Group for Food Packaging. The very good team of Imagineers. I hope they will continue to imagine and to shape the futures. We need guys like you. Congratulations.
Thank you very much.
Thank you so much.
Thank you. We really appreciate it. We are super happy to be doing it.
Yeah, thank you for the opportunity.
Thank you very much indeed. It's really a pleasure to see also your suggestion, idea, and everything. And then now I would like to activate also Gerhard Schleining, if he's around, to announce the winner that will receive the award by the ISEKI-Food Association. And the winner is Smart Pastry, use of a natural potential of non-typical species of wheat to extend the freshness of pastry. And if they are somewhere around, we can try to, and Gerhard as well, are you?
Yeah, I also want to thank all the people who contributed to that, and also the evaluators for this nice competition. I could not follow all this presentation this morning, but I followed some, and I was really impressed by the quality. And I would like to congratulate you to your success. I've seen the scores were very close, so also the others were very close to win. But of course, somebody has to win, and you got the highest score related to the criteria. And I would like to congratulate you and hopefully you will continue with your work also in the future. And yeah, I think the administrative things we can talk later. I need some bank account, how to transfer the money.
Yes. Actually, I didn't mention this aspect, that actually all the teams receive a very close scores. So the competition was very high, but actually we received the evaluations independently. So we just make the average, and collected also. I collected also the notes and the comments, and so it was really a nice experience this time with interesting projects. As already Gerard mentioned, we have to now. We have now some administrative aspects for these two teams to deal with, but obviously you will receive emails from Gerard or IFA, the ISEKI-Food Association, our secretariat, and also as regards Luciano and GSICA, we will be in touch with the Imagineers group. So we will send you all the details for managing this aspect. I just would like to close and end my presentation, because there is another slide here that I needed to show to all the teams, because we ask now to give the evaluation. All the teams will receive a questionnaire by Line that to collect all your comments, notes, because we would like to improve year by year the organization of this competition. Okay. And last but not least, obviously, all invited to our conferences, both at the ISEKI-Food and the SLIM, which is the Shelf Life International meeting planned in Naples in 2019. Sorry, there is an error here. And the conference will be in July 2018 as regards the ISEKI-Food in Stuttgart. And last, obviously, is to be ready, let's say, for the next FoodFactory for us 2019. And obviously, you will be welcome again if you are still student, hopefully as a PhD, why not, to participate. So that's all from my side. And so that's it. Luciano.
I would like to thank also the organization, because for me it's the first opportunity to join this very nice competition, and I want to congratulate for this Paola and Gerard, because I really enjoy this new experience. Thanks to everyone.
Thank you. Yeah, thank you, Luciano. Thank you very much, Luciano, and the collaboration with GSICA was for us important, because we are also more close we have a more close interaction with the food industries, and in this case packaging and so on, which is rather important also for the students, because they have also to learn about it. So if there are I would like to thank and congratulate to all the other teams. Actually, it was a pleasure from my side, and I will also bring to you the compliments from the other scientific committee members, in particular Cristina Silva, Florence Dubois-Brissonnet, Christophe Cotillon, that could not be with us this morning. And also we have also the compliments from the industry representative that you have tested this morning with the questions. She was really interested to all your projects. So thank you very much. And this is what would be my message to you all. And it was really a great experience also this time to share with you.
Thank you for all the arrangements.
Yeah, thank you so much.
Thank you very much indeed. And
thanks a lot. Yeah, it's really
good. If there are any other question and comment, maybe the other participants, if they would like to say some words. If not, we can conclude here this second edition of the Food Factory for Us 2018, and we'll be in touch with you for, we will send you the information about the next edition for sure. Okay?
Okay.
Thank you very much. Bye.
Bye.
Bye. Bye.
Bye.